Testing 1, 2. Okay, there's nobody here to see me on, so ladies and gentlemen, please welcome to the stage the amazing Niall Crosby. Woo! Thank you. You're too kind, considering I'm sure most of you don't know who I actually am. Well, my name is Niall. I work in the finance world here in London. I'm a full-stack developer, but the last few years I've been focusing on JavaScript and building internal applications using JavaScript. I started working in finance. That means we've got finance data. So we need to show large amounts of data on the screen, and we do that using a data grid. Now, I found some difficulty in finding a data grid that suited my needs. What I wanted was a grid that was fast at managing large amounts of data. It had to have an API that I liked, which was a JavaScript API. It had to have the basic features I needed, like grouping, filtering, pinning, and it had to work with AngularJS. So with some difficulty trying to find a grid to suit my needs, I went and I built my own one. And that's what is the result is AG Grid. Not to be confused with NG or UI Grid. They're different projects. AG Grid is completely separate. So yeah, it's a fast, feature-rich API for Angular. Now, I'm sure some of you haven't actually seen the grid, and I'm going to use that as a basis for the talk we're going to have on performance. So I'm going to have to give you a quick demo. So this is the grid running in Chrome. Let's do a quick zoom in and zoom out. The grid currently has, on screen here, it's got 100,000 rows. And we can see that the scrolling is very smooth. So there's no even whiteness on the screen as I go up and down. It also has very fast searching capability. So it's very quickly able to take out the values from the 100,000 rows. We've also got some Excel type filtering. And then lastly, I'll show you some of the grouping features. So there I was able to group the 100,000 rows into sections in a couple of milliseconds. OK. The grid, I wrote it at the start of this year, around Christmas time. I then pushed it to the community at the end of March. So it's only been 7 months out to the wider world. In that time, over 1,000 GitHub stars, over 2,000 downloads last month just through NPM. So I don't know how many downloads from other ways. 750 users registered on my online forum, asking questions, telling lies. So that's, looks like the problems that I've had resonated with other people as well, and has picked up some other users. When I originally looked to write the grid, I considered different ways. I looked at SVG, I looked at Canvas, I looked at doing a complete all Angular approach, and then I looked at doing a complete all JavaScript approach. What I went for in the end was a hybrid between all Angular and all JavaScript. And that's what I'm going to base the talk on today. The design of the grid, which allowed me to use AngularJS techniques, but still plug it into the, allowed me to use JavaScript techniques, but still used it in AngularJS. So the engine, the requirements in the engine kind of overlap because I kind of knew what I wanted to do before I did it. One of the things that I did was a data-driven document. So does anybody know or have heard of data-driven document? Has anybody heard of D3? This is what D3 is based on as well. To help me explain this, let me explain first what it's not. This is what you're used to doing, normally doing in an AngularJS application. You visualize what you want on the screen. We then build a template. That template is in HTML, which is a human representation of what's going to go into the DOM. Okay? We then have our bindings in an AngularJS. In the scope, we connect those up with our dynamic variables. Okay? Now, the problem that I wanted to solve, that's not very legible. Here I've got data, which is row data, and here I've got my column definitions. That's data and metadata. What I want to do is get that data and metadata into the DOM. And I'm a developer. I write code. So I want to do that by only using JavaScript. I don't want to use HTML. So I got this hunch. What if I just skipped the HTML piece and went straight in? And that's what a data-driven document approach is. So this is roughly the algorithm that's being used. I'll just make that a bit bigger so we can see it. So So I'm going through the different data items, and I'm going through the columns. I'm doing a lot of DOM hits, hitting the DOM multiple times. Once the DOM element is created, I then put in my classes, etc. And then I've got the transform. Now, the transform allows my code to make changes to the visual display based on rules that I put in. An example would be make this cell red if the number is negative. And I can do that without using any markup. Now, there's a lot of DOM hits here. Some people would say that's an anti-pattern. It's something I was concerned about, but we'll get back to that later. So that's the data-driven document. The second requirement / implementation detail was the virtualization of rows. This has been mentioned a few times in other presentations over yesterday and today, so I'll keep it short. Basically, virtualization of rows means if you have, say, 1,000 rows in your grid, but only 5 of them are displaying at any given time because of the scroll, then you only render those divs inside the browser. So based on the scroll position to decide which divs to show. And then lastly, this had to work very fast. This had to work faster than the normal parts of the application when you're inside a grid. The reason for that is if you're in an application and if you're clicking on the tabs, for example, and it takes about 400 milliseconds, just less than half a second to go from one tab to the next, the human brain is not that bothered because it's a big change in the app. However, if you're looking at lots of data on a grid and you're trying to scroll, and in the background, there's lots of rows being ripped out of the DOM and put back in, and your frame rate is about 400 milliseconds per frame, that's about 2 frames per second, that's not a good user experience. Also, when you're filtering the data, as you're putting in your search text, you want to get the feedback to the user as quickly as possible. So we saw in the demo, as I clicked, the filter worked straight away. If you had to wait for about 400 milliseconds there, the experience wouldn't be as good. So it's more important to have very fast redraw times when you're inside a grid. And then the non-requirements. The grid is a component. It's not an enterprise application in its own. So a lot of the enterprise application features that you get in AngularJS, such as form validation, reusable modules, routing, the HTTP services, they weren't really my concern. So that's why I kind of went for, let's use JavaScript for writing the core and then plug it into AngularJS afterwards. So how fast did it actually go with just those base ideas? Oh, that's not the next slide, this one, I'm sorry. Working with Angular 1. I wanted to do 2 things. I wanted my component to work inside an Angular application, but I also wanted Angular to work inside my component, which wouldn't be normal if you just get another jQuery grid. So after I've created my row, I will then do some old school Angular 1. I'll create a child scope, compile it, associated with the row, and then that will allow me to put Angular bindings inside the cells. So the grid itself doesn't use AngularJS, but it allows the application, if it wants to do customized rendering inside the cell, to use AngularJS there. And then lastly, if I make any changes inside the grid where I need to get the AngularJS application to update, then I need to call scope.apply. This is probably the least interesting slide I have because I know everybody's interested in Angular 2, and this is all old news with Angular 1. But we'll come back. So how fast did it go? I timed this with the test as follows. The demo page, which we saw earlier, I loaded it up with 100,000 rows. I then scrolled to a random scroll position and timed how long it took to redraw the screen again. And the results were like this. So Chrome was the fastest at 88 miles per hour. Firefox came second at 101 milliseconds. And then IE was third at 763. Now, you probably notice I'm looking at the desktop browsers because that's what I do. I write desktop applications. I don't have Safari there because I work in an enterprise environment where basically the rule is use Chrome when you can, IE when you can't, because you're blocked sometimes from using Chrome. So my interest is really trying to get Chrome fast and get IE fast. And this shows me that IE is slow. With that experience, that's like just over 1 frame a second, which is poor. If you're trying that on your first-person shooter, you wouldn't get many hits. So first thing I tried to do to speed it up was to introduce a virtual DOM. I've said I was doing a lot of DOM hits, and that's been hinted as an anti-pattern, that each time you hit the DOM, then that's an expensive operation. So I wanted to introduce my own virtual DOM to see if I could delay all of the updates into one big update at the end. I could have maybe used React or for some other framework, but I wanted to keep my grid framework agnostic and not have another dependency. The last thing you want when you use my grid is to have your stack get more dirty. So my virtual DOM looks a bit like this. I wrote a JavaScript class to represent an element that looks similar to a DOM element. The same attributes. We've got a type, which would be a span or a div, the classes, the CSS styles, and then the children. So that's a composite design pattern inside the virtual DOM. As I'm creating the rows, I would add them to my virtual DOM. The rows contain cells, the cells contain more detail. And then when I'm finished, I would call toString. And toString would give me the HTML equivalent of the DOM elements. I would then call that string and set it to the inner HTML of my view container, which is containing the rows. That's loosely how it worked. So with that, I was looking forward to seeing what difference it made. So the virtual DOM results. This is my leaderboard. Chrome was 88 milliseconds per second, 88 milliseconds per redraw, and that increased absolutely nothing. It made no difference at all. I was a bit disappointed because of all the stuff in the web about virtual DOM being really fast. I was expecting that to make like a 10-fold increase. But anyway, let's go into Firefox. Firefox 101, and that went to 88 a second as well, or 88 milliseconds, as if my test was stuck at 88 milliseconds. But it wasn't. I double-checked my code. It just happened to be a coincidence that they all fit out at 88. IE went from 763 to 380. That's my kind of confused face, by the way. It's like, it was good, but I wanted something to make it go 5, 10 times faster, to make it a really good experience. So I was disappointed. It took me about 4 days to implement this, and I thought it was onto a good thing. So it's back to drawing board. What else could we do? Experiment number 2, DOM recycling. This goes a bit like this. I was thinking, if I created a skeleton, if I created a skeleton for the rows, and then, so if I was trying to display 10 rows on the screen, I'd create 10 skeletons. Then based on the scroll position, I would change what was put into the different kind of placeholders. So if the scroll position is at the top, one of the skeletons would have top at 0 pixels, and then would fill in the details. And then as the user scrolled down, I would reuse the skeleton, update the top position, and update the details as well. Makes sense. So did that make a difference? My leaderboard, Chrome 88, went to 88 for VDOM, 78 for recycling. It wasn't that much of a difference. It was basically the same ballpark. Firefox went to 53. One thing that surprised me was now Firefox is faster than Chrome, which is a bit surprising. But still, twice as fast just for Firefox, I don't know, IE. Oh, I think that's inconclusive. I don't know what to take from that. So I was like really wondering, what can I do? If you go online and you Google how to make DOM operations go quicker, you find hints towards, don't do direct DOM manipulation, use inner HTML where you can, because that's like a batch operation. Recycling the DOM, wasn't too much information on that, but there's also another thing called document fragment that I tried as well. Document fragment is building the DOM offline, and then once the DOM is created, you then plug it into your browser. That made no difference either. It made no difference. I didn't even bother testing it. I just plugged it in, made no difference, plugged it back out. Then a bit more research on the web, and I came to the conclusion that modern browsers, they do that batching for you. So as you're updating the DOM, the browser doesn't update, as your JavaScript is updating the DOM, the browser doesn't update in real time. It will wait until the JavaScript turn is finished, and then do all of the updates for you. So this advantage of the virtual DOM just doesn't really make sense for modern browsers. This kind of makes sense then as to why it made no difference with Chrome and Firefox, but it did with IE, because maybe IE is lagging behind in their implementation details. I also found another interesting article online by a gentleman called Mike Rento, who in 2014, which is quite recent, was looking for similar answers to me. Now, he's working in a mobile environment, but similar browsers in mobile as there is in desktop. He found that comparing these different ways of trying to make the DOM go fast, it made very little difference between the 10 to 15% on modern browsers. So kind of wasting our time. So it looks that doing direct DOM manipulation works fine in modern browsers. But there was still, but then the winner. Which one did I pick? Well, I was saying my interest was in Chrome and IE, so I had to go with the one that made IE faster. So I'll stick with the virtual DOM in AG Grid until they catch up, and it'll make no difference there as well. But there was still a problem, and that was with the IE scrolling. Let me just show you what I mean by that. So this is the way IE was behaving. You'll see the scroll, if you can see that. My mouse, the scroll is following the mouse. It's very jerky. What you can't experience is what I am doing that as a person. That's very annoying. So annoying, people are on my forum saying this is unusable in IE. So I was running out of tricks. The trick I went for was throttling the scrolling. Pretty simple. So throttling the scrolling means it will wait until the scroll is finished before it redraws. It may not look much when you're not using my laptop, but as a user, that makes it much more smooth. There's no jerkiness. When I put this in, I did a release of AG Grid. People stopped complaining about it on my forum. So either that fixed it, or all those people died. I'm hoping they didn't die, obviously, because if they didn't, then I've still got problems in my grid. That's the algorithm for doing the throttling. Small trick. OK, so what did I learn? Well, a grid is a specialized problem. It's doing bulk redraws onto the DOM. Because of that, then, well, I went for direct DOM manipulation rather than a template-based approach. The data-driven document and the direct DOM, well, they tie in. And then for IE, to get it working fast there, I went for the virtual DOM and the delayed scrolling. And then to get it to work with Angular, I had to use the compile and the scope.apply, which is, again, a bit boring. So let's get back to the future. Oh my God, not even a single laugh for that? Probably not the first time today, OK. All right, so this is the interface we had for Angular 1. All of the details were given to the scope in one big blob object. That's kind of seemed to be the reasonable thing to do because Angular 1 scope wasn't the best for passing in two-way bound callback functions, etc. So we can see here the different pieces. We've got the call defs, the row data. Call defs, the metadata. Row data is the data. Selection is a property. We've got some events. And we've got some of the transform functions. Just to go back to the transform function, that's all you would need if you wanted to make a piece of text red. It's all in JavaScript, no HTML. Oh, and then we've got the API down here as well. The API is put onto the grid options. So I wanted to see how easy that would be to map on to Angular 2. So we've got properties, events, APIs, and transforms. Now this table shows the grid on the left-hand side, what I had. Angular 2 is the second column. Then we've got web components, because Angular 2 components are very similar to web components. And then we have the Angular 2 data change detection, which is what happens as an equivalence instead of calling scope.apply. So the properties, example in Angular 1 is the properties what we put onto the .blob object. And in Angular 2, using AG Grid, we just bind the properties with the square brackets. We've got complex properties here looked up on the context, and then we've got a simple property, which is just a string or a number value. Oh, and then the data in, I forgot to mention. This is data going into the component, so there's no data change that AngularJS needs to be aware of. So there's no kicking off of the change detection. The change detection, if anybody doesn't know, it's kind of an equivalent to kicking off the digest cycle in Angular 2. Next thing is the events. In Angular 2, events are connected up using this the normal brackets. For a Angular 2 component, those events are using the event emitters. In web components, they're the native browser events that you can extend and add your own events in web components. The data change, that indicates data going out of your component. So in Angular 2, when you fire events, that tells Angular 2 that it needs to update its, needs to do its data change detection. So there's no need to call scope.apply. Then we have the API. In Angular 2, that API ends up on the component's controller. In a web component, that API ends up on the DOM element. And then the data change, well, there's no direct data change from calling an API. But if you do cause a data change, then it should fire an event afterwards. And that's how Angular 2 picks up on some data has changed inside, well, the data change from your component, which could impact what Angular 2 is responsible for rendering. And then the transforms, that is the business rules that I had in for highlighting the grid in slightly different ways based on what the data was. There's no equivalent really in Angular 2 or web components, but that's absolutely fine because there's no data change. So there's no reason for it to know about stuff that's inside the grid like that. The digest cycle that we had in Angular 1, we used to call scope.apply. In Angular 2, we call nothing. And there's two reasons for that. One I touched on earlier, which was that if you fire an event from inside your component, that kicks off the change detection in Angular 2. So there's no need. The second reason is because of AngularJS 2's use of zones and Zone.js. Basically, what Zone.js does, well, amongst other things, one of the things it does is it intercepts all of the JavaScript start events, which are events from browser events, clicks, etc., and also timeout events. If my component is doing work as a result of any of these, Zone.js will notice, and then when I'm finished with my VM turn, it'll then do its data checking. So there's nothing I need to do. I say here ng only because that's only for Angular components. It doesn't apply for web components because web components are not executing inside the Angular 2 JS or the Angular 2 context. So no more wrapping code. If I have a component that's not written in AngularJS in Angular 2, I have to call scope.apply and be mindful that it wasn't an AngularJS 2 or there wasn't an AngularJS component. In Angular 2, that's not really the case anymore. And this is how the grid would look configured using the Angular 2 configuration. We saw this from the previous slide. Angle brackets. No brackets means it's just a property. It's not looked up in the scope. We've got the events connected up here. We've also got a label on the grid. That label gives it an ID, which can then be used to call the API of the grid. So above, we've got two buttons, which are calling the API. Now, what I find interesting here is that I wasn't thinking of Angular 2 or web components when I wrote the first version of AG Grid. But I was using best practices. I was using events, callbacks, properties, etc. Angular 2 and web components were also going down the same path. So it was quite cool when I discovered for Angular 2 that we'd converged, both using the same best practices for the web, and they fit really nicely. So where am I going with all of this? Well, that's how the grid went fast. I did direct DOM manipulation, bulk redraws. Yep, it was good. But I also spoke about connecting in with Angular, Angular 1, Angular 2, web components. And I think for me, this is the key, a key difference between Angular 1 and Angular 2, is that Angular 1 openly embraces non-Angular components. So that's, to me, relevant in two areas. The first is web components. Like web components are not necessarily going to use AngularJS, and it'll work. And the second is the Angular components themselves, because it's the same interface. So inside the Angular component, you don't need to use the template-driven approach or any other part of Angular. You can pick and choose what you want, do it yourself, and as long as you're sticking to the event type notification that something has changed, it should work. So yeah, I guess when you're writing your components, maybe sometimes you're doing something specialized, a bit of direct DOM manipulation. It's not that bad idea. Sorry, it's not that much of a bad idea. That's it. Thank you very much for listening.